In this video, we'll look at examples of standing waves, both in transverse and longitudinal type waves. First, I'll set up a spring to vibrate longitudinally. I'll connect my sine wave generator, which provides an electrical signal, to my mechanical vibrator, which shakes the spring up and down. In other words, the spring is vibrating in the same direction that the wave is traveling. That's the definition of a longitudinal wave. I'll turn on my vibration device and dial in a frequency, and I'll set up a standing wave. This video is not paused. The spring is vibrating. There, I've paused the video now so I can show you this region right here. The spring is not vibrating, or it appears to not be vibrating. Here the spring is vibrating a lot. Here it's not vibrating. Here it's vibrating a lot. This is a standing wave. It's an interference pattern created by vibrations traveling up the wave and reflecting from the top and then coming back down the spring. That sets up an interference pattern, and this is where destructive interference occurs. This is where constructive interference occurs, destructive, constructive, and this is a longitudinal standing wave. Now let's vibrate a string transversely. A transverse wave is when the medium, in this case the string, vibrates perpendicularly to the direction of travel of the wave. In other words, the wave is traveling along the length of the table, but the spring is vibrating across the width of the table. As I dial in different frequencies, I set up standing waves with different numbers of nodes, antinodes, nodes, antinodes. The lower frequencies have fewer of these nodes and antinodes and these eye-shaped regions, and the higher frequencies create a standing wave with more nodes and antinodes. Not every frequency creates a standing wave. These are only at certain intervals of frequencies that the standing waves are created.